speakers here today. So, Arun?
Yeah, thank you. So, first of all, thank Shrikant and Dataguise team for arranging this and having us here. And thank you guys for actually taking time on this amazing weather and driving without rain, right? It's really good. So, my name is Arun. I've been at eBay for 2.5 years. I'm the product manager for the Hadoop platform team. And before this, I was at IBM Watson team for a couple of years, and I was in a startup in the data space before. So we are like a team of 7 people from eBay, and also previously eBay and PayPal were together, and we had a huge Hadoop team. And we thought and one of the things that we had was eBay has around 800 million listings on the site at any given point of time. There are close to 800 million listings. So with that listing, we have lots of data that comes with the listing. For example, it could be the image data, or it could be the title, it could be the pricing, it could be different kind of data that comes up with the listing. And so we thought, okay, what's the best way to store this data? And we thought, okay, let's go with having a huge Hadoop presence. And we have today we have around 7 Hadoop clusters with 120 petabytes of data. And this is both structured, unstructured, and some kind of semi-structured data. And any given day, on one of those clusters, we have around 800 million HDFS operations. That could be someone writing a job to read a bunch of files, trying to come up with recommendations and reports. So there are a lot of read events. There are people are trying to delete data, or people are trying to move data back and forth. So this was some of the statistics of our Hadoop cluster or Hadoop environment is laid out. And when we looked at, okay, we have 800 million events, do we know what these events are? And eBay went through a security breach last year, and it was really bad for the business because once there's a security incident, there's a lot of things that you need to take care of. One is the brand reputation, etc. So we thought okay, what is the way that we look at data security? Is we really look at these 4 things. First is do we have enough authorization and access control around the data repositories that we have? And the next one is the perimeter security. Is the firewall secure? Do we have all the ports closed? Is it tight enough? Is that 2FA enabled so that people can authenticate with 2-factor, etc.? And then the data classification is the most important piece, because without knowing what data is there in the cluster, it's really difficult to say that, hey, you know what, out of this 120 petabytes, 5 petabytes are classified information. Do we have address, we have phone numbers, bank account details, we have email address, etc. So how do we get those classification? So we use Dataguise for classifying all our unstructured data, structured data in other clusters. And we almost had a product for each of those areas. The one piece where there was a big gap was in the monitoring. There was no tool back then when we started in the security journey to say who is accessing what data. There are around 2,000 Hadoop users within eBay and PayPal who write MapReduce jobs and Hive queries every single day to read and create reports. And we didn't know who are these guys. It could be finance people, it could be marketing folks trying to read the data, but we didn't have a holistic view of what's happening. Another thing is, even say for example an intruder somehow gets access to one of the user's account and they are trying to read the data, it's very difficult for us to catch it, because at any given point of time there are 800 million operations, and that could be one of those operations. It's very difficult to catch. So there was a huge gap in the activity monitoring, and we thought okay, let's develop a system called as Eagle. And we developed Eagle for the past 6 months for this use case for the data activity monitoring, and we open sourced it last month using Apache incubation. So we are an Apache project right now, and there's a lot of activities that is going on, and this is actually the first meetup that we are doing kind of an outreach. So the definition, it says, right, it's basically an activity monitoring framework to recognize an attack, and not only just recognize it, but also it will give you the ability to go and stop an attack. And it actually, I'll explain you how that works. So this is kind of the tools that we use within eBay. We have fine-grained ACL for each of those data assets. And then the monitoring tool is exactly what Apache Eagle does. And the classifying encryption is where the Dataguise product really helps us. So the high-level Eagle architecture, so we have data sources. So in any Hadoop cluster, you would always hear about like 2 or 3 different patterns, right? You will say like some people say there's a lot of HDFS data, they write MapReduce jobs, and some people use Hive queries to access the data, and some folks like use HBase if they want to use a columnar data store. So any kind of data source, and there is like lots of new things coming. Right? You have like Spark, you have Kafka, you have Storm. There's like a lot of different kind of access points. But at the end of the day, the data is still in the HDFS layer. So we thought, like, okay, we will have a data source, and this could be anything. Today we support HDFS, Hive, and HBase, and we are planning to integrate with like MongoDB, Teradata, or any data store for that. So from the logs, it actually goes to the real-time processing engine. That's like the meat of the whole Eagle. I'll talk about a little bit in detail. And the Eagle service is kind of like an API where you can define policies, you can get alerts, etc. Oh, this is the most busiest diagram. So from left to right, as I said, you have different kind of audit logs. For example, like the first 3 versions we support today. So today, if you download Eagle, you get all of this out of the box. So we actually pass through Kafka, and we have different Kafka topics, and in the middle, like the entire processing happens on Storm and Spark. I'll tell you like what happens in Spark versus Storm. So once inside Storm, say for example, an event comes in, and in this area, what happens is you apply policies. For example, like our InfoSec team who kind of like gives us like, hey, these are the set of policies that you need to monitor for. And we will tell them like, okay, go use Eagle and create a policy saying that any user who is deleting data more than a petabyte, we should catch that information. Not only that, we need to use those create reports at the later point of time for auditing or different like security purposes. Right? So the entire thing happens online in real time using Storm, and the bottom piece is like the machine learning. For example, there are 2 kind of policies, right? One is okay, these are the policies that I want to add to the system, but there are always corner cases where certain static policies cannot catch an event. For example, that's why think of an example. For example, out of the 800 million events, we want to figure out how many users are accessing a data that they never accessed in the past. It's kind of like an anomaly detection. So for example, Arun is from marketing. He always uses marketing data for the first 100 days, and suddenly for some reason he's going and using finance data. Maybe that's him changing roles, or it could be someone is got into his account and trying to use the data that Arun never accessed in the past, but it's more sensitive. So those kind of anomaly detection. So what we thought was we will come up with 2 machine learning models which actually already learned some of the actions that are happening in the cluster, and based on those models, it will start creating alerts and events and trigger alerts for those events. And at the end of, okay, this is like the main important processing. But on this side, what you have is like, okay, some people use Tableau for reporting for BI, right? So what we thought was Splunk is one of the tools that's being really used for monitoring purpose for security for other data source. So we thought like we will have third-party integrations with monitoring tools, but also we have like an analytics dashboard where you can actually see some of the basic analytics on the security. So I'll talk a little bit about the functional features of Eagle. Okay, on the top you can see the raw event. This is how an event looks like from the audit log, right? Today, it's like just a bunch of random text that actually talks about when the event took place, what kind of command was used, who's the user, and what action did they do. And this is the raw event from the logs. And the policy itself is like you have 2 ways to define policies. You have in the UI you can set policy, or you can actually do it from the API. In this example, you're saying if the data is private, or this is kind of like this is the folder, and then if somebody is trying to use this command, get file info, which is very common, and this is the stream, alert me, right? Out of 800 million events, if something matches this particular policy, I should get an alert. And the alert, how it looks like is, it says like user Storm, they're trying to access some private information. There is this whole sensitivity definition, security zones, from where they're accessing, etc. So this is like the basic event policy alert definition.
So is it okay to ask question now or for the questions today?
I mean, we can ask questions on this one.
So the logs themselves, are you reading off the disk like HDFS logs returned to the disk, or you are putting some hook into HDFS, so you write to Kafka, you get the Kafka events,
So
how does it work?
Before it moves into HDFS, we actually catch it using Kafka. So we actually stream those HDFS log events.
Oh, you stream HDFS
Yes.
logs. You put some code in main node or?
We use Logstash.
Yeah, we have two ways. One
Yeah.
is log stash, and the other way is a log4j appender.
Okay, okay.
Yeah, that's a pretty.
And you do the same thing, so which means you are using basic HDFS logs. You
Yes.
don't use Ranger audit.
Not yet. So actually Ranger and Sentry has like a consolidated collection. So we are actually planning, actually Don Bosco from Ranger team is already starting to do that.
Okay, you are working.
Yeah.
Okay, great, thanks.
Thanks. Any other questions so far?
So the policy engine, is that based off of anything like XAML or any of the other?
Siddhi, we use like Siddhi policy engine.
Okay. And can they be nested with policies?
Yes. So for example, I can apply 5 policies as like child, and this is like a parent. I can say, out of this policy, I want to create one more policy like an aggregation saying that it's not only get file info, but I want to like read more than 20 megabyte. Then it will take like, okay, first the policy, child policy get executed and then goes to the
So what is the policy engine you mentioned?
Siddhi policy engine, CEP engine, right?
Is that open source or?
Yeah.
So that's the Apache license too. CD.
SIDDH.
Just say,
Yeah, I'll talk about that. Okay.
Yeah, I think Edward is going to cover in detail. So today, right, once you install Eagle, it takes around, it depends. So for me, today we released the Docker container for Eagle. It takes like 2 commands that you can run using your Docker native commands, and Eagle gets installed within like few minutes. And to go production, it might take a couple of days because you need to kind of like start using Eagle, right? So once you install Eagle, what you get is like the ability to create policies, right? On the top left, you can see this is like the navigation bar, right? And you see like the list of policies you can create, and for each policy, you need to select a data source. It could be Hive, HDFS, HBase, and based on the data source, the streams will automatically get selected. For example, for Hive, it will be Hive query log. For HDFS, it will be HDFS audit log. For HBase, it will be HBase log. And once you have the stream selected, you can define the alert policy. For example, like I think I talked about what kind of match criteria. So this could be commands, this could be different kind of operations that are happening within the Hadoop cluster. And we have some external metadata like host security zone. One thing in eBay is you have something called the secured zone, and the other like zone is the corporate where your laptop is. So if you want to monitor traffic between your laptop and the security zone, and you can set policy saying that, hey, if there are more than 100 connections from the corp zone to the security zone reading this particular file, I need an alert. So you can set those kind of events. And for the sensitivity type, it's basically, this is the integration with the Dataguise piece, right? So the idea is the Dataguise DG Secure will tell us, hey, this is the classification of your file system, basically. And we can have flags saying that any sensitive data or any confidential data, I need to set an alert. So this actually you can import, we're working on the integration on the metadata layer, right, to get more of the metadata flow into Eagle. So this kind of like the user interface. And we also make, have some sensitivity browser where you can actually browse through the HDFS folders or files to mark certain items as sensitive. This is to actually enable more integration, lightweight data classification. This is not automatic data classification, it's like manual, right? For you have to actually go and say that this is sensitive. The idea is to have Dataguise like kind of like plug in and say that you don't have to really go through this step. Any questions so far? Or so I think this example is more for the HDFS files and folders. And this example, it shows for a particular database in Hive. So I kind of like select the database. I say, okay, these are the column names. Out of this column name, phone number is actually sensitive of the type phone number. Once I say that, okay, this is the metadata, I can actually go back and create a policy saying that, hey, if anyone accessing this database and of the sensitivity type phone number, you will get an alert. So these are the kind of thing events today we support, HBase, Hive, HBase, and like different hierarchy, right? You have HBase site is how many clusters. So one Eagle instance can monitor multiple Hadoop clusters. So today we do one Eagle instance to monitor 7 Hadoop clusters of different versions, etc. And then different files, folders, where you have the whole set of like Hive and HBase column family, right? And the attributes, I think there's a whole list, and we're planning to extend to more external metadata information. So.
Good question.
Yeah.
So, in cybersecurity and in general, one of the key things is that threats are taking place. You have the data, but is there a way, and people don't act on it like target, and is there a way that the leaders are doing is to kind of figure out what threats the company should actually work on first and then kind of work on the other ones later on, kind of a prioritization?
That's a good question. So we don't, currently we don't. For example, usually it's the eBay, the InfoSec team or information security comes to and says that, based on our experience, these are the policies that you need to have. They usually say, okay, PII information takes precedence over like some random information about it. So, yeah. Right. So the integrations. Okay. One thing I think I mentioned was it's not only for monitoring and alerting, but also going and stopping an attack from really happening. Right. So for example, let's assume some random hacker got into my account and they are trying to delete 1 petabyte worth of data from the eBay Hadoop cluster. Previously, they could do that. Like today, they cannot because Eagle will catch it in real time as soon as I execute that delete command, and we will trigger an event, and you will say Ranger is the more access control policy, access control product, right? It will actually stop this user from finishing that command. It will remove the access to the particular data set. So that command actually won't go through. If you think about it, like it could be for read, it could be for delete, it could be for data copy from one place to the other. So you actually stop a particular threat event from happening. And so exactly, so this like everything is not done by Eagle. It's just like integration points. So DG Secure, I talked about like the data classification. For Splunk, what we are doing is eBay also uses Splunk. Actually, the InfoSec team uses Splunk for monitoring network, databases, and different areas apart from Hadoop, right? So what we worked with them was we will send the alerts as syslog format. So the feature is already there in the open source version, and we will also ship the alerts to Splunk so that you can do multiple layers of abstraction in Splunk. The one thing is you don't have to send like whole petabyte of data to Splunk, right? Because it's expensive. But on the other hand, you can also do one layer of abstraction in Eagle, and for other processing with correlation with other data sets, you can use Splunk. Edward? Sorry.
Quick question. When you talk about the policies action part can be tied to Ranger, for example?
Yes.
So that's how you kind of, surface that.
Right. So, for example, I think in the configuration and notifications, in step 4, once you define a policy, you can say that, hey, do I need email alerts or do I need it? Automatically, everything goes to the dashboard. And if on top of it, if you want email alerts or if you want remediation, you can select and checkbox and say that, hey, for this kind of policy, if it gets triggered, apply this action. That piece is still in work with our Ranger guys in the community. Edward. Let's start right left.
Okay. Thank you, Arun, to bring up the business features. I will take time to look at the details of the technology part. Eagle team is actually a very small development team. and we have like 5 or 6 developers. But we are very passionate on to look at the monitoring tools, because when we start to monitor eBay Hadoop, we saw a lot of issues because the high volume of the data. Say, for example, we have a cluster which has 2,500 machines. So in that cluster, each day we generate about 2,000 jobs and millions of tasks. So how do you monitor the job performance of those large clusters? So that's a very challenging. We tried to look at a lot of monitoring tools in the market. For example, the Zabbix, Ganglia. But when you look at these traditional monitoring tools, you will find that they're not very scalable. They don't care about the fault tolerance. Their policy is, for example, in Ganglia, you cannot configure the policy, right? So a lot of issues, and in the market, I don't see people are seriously to do innovation on the monitoring part. That's a problem. So that's why we take a long time. About 2 years ago, we started the developer Eagle and try to figure out some innovation on the monitoring system. So here you can look at. This is a normal one. I believe every monitoring system will look at that. Is how to ingest your data. That's pretty straightforward. For security case, mostly we will look at the audio log, whatever is from HDFS or it's from Hive query or from the HBase query, we can get that. Normally we support the Log4j and Kafka, but that also has some issues because that means Log4j append is running within the nemnode process, right? And also, if you apply some very complicated partition rules in Kafka, then it will consume a lot of CPU resources in nemnode. So in eBay, we don't use this approach, but for a small cluster, we can try this approach. So in eBay, we try the second one, which is the Logstash. But even for Logstash, there are some problems because in Logstash agent, right, you also have a very complicated regular expression. That will cause a lot of overhead in the nemnode. So today we also use the 5-bit, which in the nemnode side, you just transfer the log. And in a 5-bit, you can apply your rules. The rule means probably you want pass the whole log of your pass the log and to figure out what is the user and partition by the user. So that's a complicated logic which consumes a lot of CPU resource. For Hive, how do we get the Hive query log? I believe that's very challenging. So today in production we use a way of Yang API because the Hadoop tool support the Yang to run the MapReduce job, right? And Hive will always will spawn a new MapReduce job, so that's why we use the Yang API. But that also has challenges because like Hortonworks has a test, right? You can run your query without MapReduce, but with the test. So that's you cannot get the Hive query. Right? So that's also a challenge. But the perfect solution should be the Ranger, I believe, because the Ranger has a very uniform Log4j format for almost all the components in Hadoop. HDFS, Hive, HBase, Solar, and the Storm, etc. has a lot of uniform format of log. So that's very good. Eagle will integrate with Ranger on that also. So quickly go through this. For HDFS active monitoring, we mostly partition the traffic by the user. Why do we do so? That's because most of the meaningful rules is based on the user, right? So that's why we always net the events for a single user always go to one single box. So we will keep all of the message for this user. So that's why we partition the user all the way from the beginning to the end. But that also has some issue. I will talk about that later on. For high activity monitoring, like I said, we use the Yang API. In the bottom, you can see the Yang API. We get the Hive query from resource manager and from the job configuration file. And also this solution is also scalable. Whatever how many jobs you are running, we are partitioning our processing. For example, in the right side, we have several partitions, right? We have partition 0 and partition n. So that means our data ingestion is also scalable. So that's very important, especially in eBay environment. So I will talk about any questions so far for this one? Okay.
So from what I understand, the sort of three pieces, there is the ingest piece, there is the policy execution piece, and then there is the action piece of this. So if you look at what we have today, like this Ranger and the Sentry, they have already implemented many of these pieces. So what made you re-implement the whole product rather than adding an adapter to one of the existing projects to accomplish your use case?
Actually, for those ingestion, we don't spend.
Ingest probably is fine, but let's say the policy engine, that you need some way to define your policies, some engine to execute your policies and then take the action.
Right.
So have you considered adapting to one of the existing projects or making your project complete using pieces of that rather than re-implementing the whole?
No, but range policy is very different. Range is for ACL control, right? So you know what user can access what, so you set the rules. But for the monitoring, it's very different. For monitoring, you want to know who has accessed what data, who has exceeded the quota you assign to the user. So that not range can do. So ACL is very different from the monitoring. That's my understanding. Yeah.
How complex is it to maintain the rules engine? I mean, I've got to imagine that you've got lots of rules, and then does it generate a lot of false positives? You constantly tuning?
Actually, for the false positive, we need to be very careful because there are several ways. One way is to do some deduplication, right? For example, for the same user, you don't need to alert every time within 1 hour window, right? For the 1 hour window, probably you just alert one time. But for the false positive, for the rule-based, that's I think that's depend on the rule itself. If you believe in your rule, then this should be a good one. And also, okay, I think that's fine. Also, like Arun said, we have an integration with Splunk. So in Splunk, people can manually analyze the alerts. So you can set up the rule and output some first abstraction of the alerts and use manual work to figure out who is actual malicious user or activities.
How long does it take you to bootstrap the system? So you have 2,000 users that are accessing your Hadoop infrastructure, right?
Yeah. So,
Yeah.
no, so for, I think for like the in eBay, the production cluster, we have around 80 policies, right? And the 80 policies are very simple to add. Like as soon as you figure out like from the infosec, okay, these are the 80 policies, you can actually set it up very easily. The policy part is very easy. But and once you apply,
These policies generally are aggregated across all these users, like no one should
yes,
have
it's
the ability
aggregated
to
across
delete.
all the users, all the users, yeah.
I have a question actually. Here's maybe my naive understanding what you explained before. You said there is a machine learning component
Yes.
to it. In other words, you're in real time generating new policies because you see
Yes.
anomalies in access. I think that's the question I think he's trying to ask you. How do you know where those are real anomalies and that things you need to go and address? Or do you first go and interrupt them? You make sure Ranger does the lockdown and then you go evaluate and see if it's truly a policy or not. Unclear to me whether that feedback loop is any human involved or you just kind of move through and you just automatically generating rules and you can start with 80 policies but then it gets to like 500.
Yeah, it could.
I don't know. So is that
So, like,
is that the right? I mean, I just,
that's actually very good.
That what you guys
That's exactly what we're doing. For example, the static policies will catch an event based on the policy itself. It's very straightforward.
those
Yes, those 80 ones. Those things that which the system, you didn't know that there was a policy, but there is an anomaly that's happening, right? Actually, the machine learning will catch it in real time. It can also send the same alert to stop that.
Can I go to the other example you gave when you talked about a petabyte of data?
Yes.
Let me tell you, I might be a smart guy and I'd say, let me delete 10 megabytes at a time and get to maybe the wrong number. Would you still catch those kinds of numbers?
Yes.
I can understand a petabyte, right, wow, that looks crazy. But if you know, a gigabyte here,
Yeah.
you there, and you start get the same thing, your system will still analyze.
You could still get it, yes. So in the when you set the static policy, today we have the file size, and you can set it the range.
So maybe one more final thing, if you are like this. So Eagle is a mechanism for monitoring policy, but your real smartness is the machine language piece, which is not, which drives the new kinds of policies. Is that right?
That's right. So machine learning, the reason we did it was first we didn't know what the 80 policies were, and we thought like, okay, everything cannot be a policy, right? So there are anomaly detection is one of the important piece of monitoring. So we said like let's have machine learning.
Oh, thank you.
So very good. Thank you.
Yeah,
One
that's
quick question on that. Do you have policy templates that are constantly being added to this, and
No.
based on your learning, are
We
you
should
adding
like
new-
that's a good feature. Yeah.
And this is almost unique. Every use case where you apply Eagle, you need to have your own little thing to drive the rules, correct? That
Right.
just seems like it.
But definitely we can drive the rule from the, for example, from the Dataguise. Because Dataguise can scan the HDFS, right? And they will find out what data is sensitive. And so we can generate the policy on the fly. So that's,
Can you stand a little further so the camera will record you?
okay. Okay, here I talk about some policy. Policy has to be declarative, right? So we don't invent a new policy engine, but our system is also extensible to other policy engine. Today we use Siddhi. Siddhi is a WSO2 company which provides some enterprise solution. And CP engine is the open source with Apache license. So that's pretty much like a commercial one, like Expert, right? Support any real-time streaming language. So that's very powerful. I believe that can solve our problem of the rule-based policies. But for Eagle, we do have some innovation on this because policy, you can hard code, you can configure in the config file, but it does not work for the changing world. So that's why we make sure policy is very easily to define and people can easily add, update the policies. So that's the engineering part of Eagle. So in the right side, we can see we have a metadata manager. In the below, we have the, sorry, you cannot see it clearly. In the below, it's a schema. So that schema is how do we describe the event, meaning, for example, what the attributes name for the events, and what the type of the attributes, and also the description of the attributes. So, for example, let's go back to this one. For example, here you can see the attributes, right? But these attributes is not hard-coded for the HDFS. That we use the metadata to describe the attributes of the events. So that's why the UI part is very simple. Just use our metadata API to populate the UI so people can set the policy. Okay, the other innovation part is pretty important. Is how do we make sure policy evaluation is scalable? So when you look at the Zabbix or other monitoring tools, it's very hard to solve the problem. So we solve the problem in the streaming because our monitoring is distributed, meaning we have a lot of nodes which running on the storm, and the policy is running across multiple nodes. So that's what we need to think of, how do we scale the policies. Because monitoring SLA is very important. Before the Eagle current version, we have an Eagle version 1, which we also collect the HDFS audio log, but we can only do like a 1 hour batch. But today, in version 2, we can within 200 milliseconds, user get operate on the HDFS, and we immediately get the alert. So within several hundred milliseconds. So how do we do this? We think of the whole system is partitioned by the 2 ways. One way is for the data partition. That's pretty straightforward because your data from a source can be partitioned by, for example, by user, right, or by machine. So that's kind of data partition. But data partition is not enough because you have multiple rules. You have like 50 rules, 100 rules, and those rules are very expensive because they use regular expression, they use pattern match. That's very time consuming and CPU consuming as well. So that's why we need to partition our policy as well. So we need to make sure we also think the policy partition is like a computation partition. So in this diagram, you can see how do we partition our system. In the left side, we have the policy partitioner. By default, the policy partitioner is hash code of policy ID or policy type, but that can be customized by the customer. If you want a different policy partitioner, later on I can talk because we can do some weighting policy because different policy have different weight. Some policy consume a lot of CPU resources, so we need to take care of how do we partition the policies.
Yes. So this policy, when you have partitioning policies, so does it mean that for a given audit event, all policies are not applied? You don't inspect against all policies?
Yeah. No, each event will go through every policy.
So it's like a
Yeah.
This also assumes that policy 0 is not
Independent.
1, right?
That's assume policy is independent.
Yeah, so that's the key.
Yeah,
right?
that's the
There's
key.
there's no dependency between two that requires you to put them together.
Right, but
sequencing.
Yeah,
That's what is partition around.
correct. That's correct. So that can be shared nothing architecture. So in the top, it's a normal one. Whatever is Storm or other streaming solutions, Samsung or Spark that support partitioning your data by any field. We mostly in security case we mostly partition by user because you take care of who access what, right? So user is the central one. So that's why. But we also realize that policy engine must be extensible because today the policy can do two things. One is probably three things. One is single event evaluation. That's the most simple, but mostly useless. Mostly the policy is window based, and also the policy can be the pattern, like A happened before B and B happened before C. So that's another type of policies. But we do have other policy. For example, before this Eagle open source, we have a policy like how do we determine one bad node within 2,500 nodes. That policy, we need to connect all the task failure ratio within each node and compare with each other. So it's like a statistically policy. It cannot be evaluated by the rules. So that's why policy has to be extensible. Another very important one is any monitoring system cannot avoid is you want your data to be enriched because whatever data from HDFS or Hive, you have very limited fields. You want to join outside fields. For example, you have a file. You want to know the file is belong to which type of sensitivity type, right? So that could be in a data store which populated by the other tools. The other tools scan the sensitivity file and populate to Eagle. This part is also some issue with the scalability as well. For example, today we want to do one thing is to pull all the name node image into the cache of the real-time processing. Why do we do this? Because in the name node image, right, we have everything of the file. We have the permission, we have the user group, we have the last modify, we have everything. So that will be very cool if we can pull the image into the cache. But problem with this is also the scale issue. How our memory can hold all the data from the image. Say, for example, in our eBay cluster, probably one name node has memory of 20 gigabytes. Right, so that's why we need to make sure the external data is external metadata join is scaled. So in the right side, we can see we have two models. One in the middle. In the middle, we can see that we can split our metadata into three pieces in three boxes, and each event will go through each bucket in parallel. The other way is each event will go through each bucket sequentially. The benefit of this is that we can still preserve the order of the messages. So we need to do some trade-off on this. Today, our external metadata join is only applied to sensitivity type. Okay, we have another innovation which focuses on how do we write a program which how our program can be extended to other data source. So this type of API is what we provide. This inspired by Spark and Flink, which are very good streaming solutions that provide very good API. So we also provide a similar API, but a little different is that we provide some high-level, we hide some complexity behind this. For example, if you invoke alert, then the framework automatically to partition your data and partition your policies. So that's why you can easily integrate another data source.
I have a quick question. Can you add attributes to events as part of the processing? So you talked about enriching the model, right? So if we wanted to add some additional things, and can that also be subsequently used by your machine learning process to insert new rules?
For example, today we use sensitivity zone and sensitivity type. Sensitivity zone is like, for example, the IP address from some other, I don't know which system, but it has like, okay, these IPs belong to corp zone, these IPs belong to the site database. Can you import that information? You can do that. And it will be used by machine learning component as
well. This is another very detailed one because the monitoring is actually a graph. So, like I say, we have high-level API like alert or external join, and behind the scene, what Eagle does is to do some expand the graph to a new graph. The new graph can be executed on Storm infrastructure. So that's framework does. Here is an example. When you write your code like this, data source transform and do some external join and do alert, then the framework will compile this graph into another graph. The below graph can be executed on Storm. So that's what we do. The API is like a right side API. It's very straightforward. Another part is Eagle service. Like we see before, we can define the policies in Eagle service. And you can also view the alert dashboards, and even you can view the metrics, very high volume metrics. How can we do that? Because our system is backed by HBase. So we use HBase as our storage, and we also develop the OR mapping and a query engine on top of the HBase. It's pretty much like Apache Phoenix, but when Eagle first developed this 2 years ago, Apache Phoenix is not ready. So, but we do have some optimization for the performance of the query, because in monitoring system, the characteristic of the data is that you have a very large volume of time series data in your system. Whatever is any relational database cannot hold that. So that's why we use HBase, and we invent some good schema for store the data, so you can immediately retrieve the data in the dashboards. So we also have other working progress features. For example, the second one is the whitelist. Whitelist is something like a user is allowed to do something except for some resources. You can only access some specific resources, otherwise we will do alerts. The other part is user command with assembly. Let me show you. So if you are familiar with HDFS, probably you can understand that in HDFS, when you write a command like a copy data from local to remote, you use this single command, but in the In the name node, it will generate about 6 or 5 granular commands. So, for example, here is the raw commands. Problem with the raw commands is that you cannot define rules against the like a copy, because you have so many commands there. So that's why in Eagle we need the user pattern to figure out what is the high level command for the user. Meaning we need to get the real user commands. Okay, the other part is very important is the state management. That's for the fault tolerant. For the monitoring system, often we have like a window to monitor the system. The window could be 1 month. So if in 1 month your system could be down, could be restart. So how do you preserve your data, right? So we have a way to persist some data. That's a very popular topic today in the streaming infrastructure, like a Storm or Samsung. They have some mechanism to persist the state. But for Storm, because we use Storm, a Storm problem is they don't provide any state guarantee. So that's why Eagle, as a monitoring system, we have to take care of this. So that's why we are taking care of this as well. The other part is data skew. Like I said, in a cluster like eBay, right? We have 1,000 users, but you can easily see that some user is very active, but some user is not very active. So when you partition your events by user, then the whole system is not balanced. So that's a problem. So the other one is a computation skew problem, which is the policy. Different policy has different weights. So probably we can look at this. This is the data skew problem. For example, we partition the user by 8 ways, but you can see in this bucket, this is the maximum bucket, this is the minimum bucket. They have 32 times. So user is not balanced at all. So that's why we also use figure out the problem with another algorithm, and we are trying this algorithm. Is working very well. When the bucket is full, it's pretty much balanced. Because in this case, it's most like some active user go to the same bucket. So that's why this bucket has a lot of events. So we need to make sure the big user can be spread out. Okay, this is how do we solve the data skew problem. We collect the statics in a runtime and then feedback to the Storm to the elastic load balance of the data. This is a computation skew problem. We don't resolve this problem yet, but probably much similar to what we do for the data skew. In this case, you can see that this is an alert. We have a 4 physical machine execute on alert. And each machine maybe has 12 policies. And this is the load. So you can easily see that some alert buckets has a very high load than the other buckets. So that's a policy problem. For the machine learning, we have one girl who is not here today. She's pregnant, and she's a machine learning expert. So I just go through a little bit on that. So the nice piece for Eagle machine learning is that we get full automation of the machine learning. Full automation meaning in the offline, we build a user profile per month. Right? For every month's data, we aggregate the data, we process and build a user profile. User profile is nothing but what the user's behavior, like how many times user does operations like a delete, like a make directory, like those. So that's a user profile. And the full automation also means we in a runtime we compare the runtime events against the history user profile and to find the difference. If there is a large difference, we alert. So that's the full automation of the machine learning. The below side is the offline. Offline is we take data from archive, from HDFS, which is archived in HDFS. That could be 1 month data. We use the Spark to process and get a model. In the right side, our model is persisted into Eagle web service, and that will fit into the online part. So that's a very straightforward one. But the good thing for Eagle is that that's for automation. But when you use the Spark machine learning, but that's only for the below side. You cannot get that online because you have to program your online. So Eagle is fully automated on that.
Actually, once you download Eagle, so previously what Chaitali used to do is like offline. She did the whole modeling, learning and everything offline. It took a long time. Whereas with Eagle, what we did was once you install configure, you can actually click one button and it will automatically run a Spark job, which creates a model for all the users. And in the dashboard, you can, for each user, you can go and click and say that what's their model look like in 3D and 2D graphics, which is not interesting, to be honest, because with the model you cannot do anything. The real good piece is with the alerting itself, using the model, is there any anomalies detected?
Is there any clustering attempted in this process in terms of clustering the events themselves or access patterns or other things to infer those, or is it more other support vector machines or other approaches that they're using to?
You mean the machine learning approach?
Yeah.
No, this part I believe only Chitali can answer. I cannot. So Eagle is fairly new. We welcome contributors. Whatever you are interested in security monitoring or you are interested in platform, because today you can see we have a lot of framework issue. Today I don't see any monitoring tools like Dataguise or Ganglia that solve these problems. So I think that's a pretty interesting project. Yeah.
And we just released Docker yesterday. Docker
Sorry, go ahead.
No, I was just finishing like Docker story, right? So previously it used to take me, at least even for me, like to run Eagle on my laptop, it took like 20 to 30 or even an hour to run it on a sandbox version. Whereas with Docker today morning I tried it, took like 5 to 6 minutes based on just 3 commands using Docker container.
So I guess the current focus is on security, but I guess the data that you're collecting can be very much useful for other purposes. Like you can see how your clusters are being utilized. So let's say you have a table with 100 columns and most of your queries are only hitting say 5 columns. So for profiling, and that can feed back to your data architects for re-optimizing.
Right.
So is that something on your roadmap?
Yeah. So we didn't talk about that actually. So we started working on it years ago, and originally we developed for those use cases like system monitoring for HBase, for the whole Hadoop cluster itself, where is there a data skew, is there jobs, or how are the jobs performing and all that. So we did not release that version in open source because we re-architected the entire platform using Kafka for real time. Previously it was batch oriented. So now our idea is to, once the V2 architecture, what we call, is released, So we will actually re-enable or rewrite those features of HBase monitoring, job performance monitoring into the
Yeah, we definitely plan the job monitoring again. Yeah, we have the code, we need to convert that to the new architecture. Any questions?
Two questions. First, what is the data storage for the alerts?
Like I said, we use the HBase, our storage, and HBase is the only storage.
Okay. Second one is, do you have any performance number in terms of how many events you can process per second?
Okay.
Based on how many rules?
We have a performance number like this. In one cluster, we have the cluster has 2,500 machines. In this cluster, the message rate is like for 1 second is 30K messages per second.
So
In a peak, 30K, 30,000.
in that case, how many rules you have?
Okay, in that case, we tried 50 rules, and then we partition in 4 ways. So each way has 12 rules. And the rule is very simple, a regular expression. And we have 8 machines, and we have like 60 excluders, meaning 60 threads. So in this configuration, we can achieve the latency from event coming to Eagle and get alerts. The latency is about 200 milliseconds.
But that's, can you say so? That's directed on data from the system, right? Partition, so you may require more horsepower. If you want to maintain the latency, you may have to add more system which is based on the workload, correct? That's
Yeah.
It's classic computational power, right?
Yeah, that's the classic horizontal scalability, right? But we do believe we can optimize a single policy because we, for example, today we use a CD, right? CDCPNG. CDCPNG is pretty, performance is pretty good. It's compared with Esper, much better than Esper. But I think we can still improve that on the single node. So today, in a single node, when we host like 12 policies, the latency could be like 100 milliseconds. Less than that, but it's not good.
I'm just curious, now that you have some production, what are some of the interesting security events that you picked up?
So the deletes, so far, like the deletes are the data copy. So in eBay, what happens is, like if you're using a laptop for running jobs, right? You're moving data back and forth between clusters. That's one common scenario we see between zones, or even like sometimes what happens is like some users, they copy data within the cluster to their home directory, and it actually duplicates the data, right? If you look at 2,000 people doing that, it's actually a cost for eBay as well in terms of storage. So those are, some of them are security related, some of them are non-security.
Okay, thanks so much.
Thanks, Arun and Edward. So we have a little token of appreciation on behalf of Media Group. We have some security blankets out here. We want to give it to you guys. And for all folks interested, please go with Prasad or Manoj. They will show you the live wall next door, and you can play it on and understand what Prism Technology is about. We will probably take a little bit of a break until end of January for the next meetup, and we are hoping to get Hortonworks back on the next meetup to talk about Ranger. Thank you very much, and thank you, Aaron, and Edward, and also the eBay team for showing up here and taking our invitation to be at the meetup here.
Thank you.
Thank you. Thank you all for attending.